Hey guys, now we're going to do lesson 2 from section 5.5. We have one more lesson in this section to finish it off after this. Then we go into chapter 6. So, the problems you should focus on are 1 through 6 all, 37 to 48 all for this lesson. Here's the answer key. In the top, 1 through 6, you'll see this when you open up the book. These are matching. So, for example, they might give you something like 2 tangent pi over 6 over 1 minus tangent squared pi over 6. And your job is to say, hey, wait a minute, that looks like the tangent double angle formula, so tangent 2 theta. And what angle are they using? Well, they're using pi over 6. So you would say, oh, that's the theta they're talking about. So they want the tangent of 2 times pi over 6, which is the, tangent of pi thirds. And then I say, dang, what's the tangent of pi thirds? And I go, I have a bow tie. Or I could just quickly sketch it right here. I could draw myself a reference angle and say, if that theta that they want me to use here is pi over 3, probably shouldn't have used theta as my thing here. Because what are they actually asking me to use? This pi thirds. So I would say opposite, adjacent, hypotenuse. And so what is the answer they actually want me to come up with? The tangent of that angle would be rad 3. That's the answer. But in this section, you'll see none of the answers have, they're all letters because those guys are matching. But that's what they're trying to ask us for. So in the first section, it's matching. I think those are easier because you can just match it and play process of elimination and get down to the end. But you'll see here, 37 to 48, all the answers there are in radical form because they're using exact values. Or what's up with these guys, like 44 and 46? What's up with those? Well, I have some examples. We're just going to knock them out. And then you're going to try and do these problems, and you'll see what I mean by these ones, these weird ones. So let's look at my, first example here. They have cosine squared 150 minus sine squared 150. I'm supposed to say, well, wait a minute, that looks like the cosine double angle formula. But what is the actual angle they're giving me right here? 150 degrees. So if they give you degrees, you're in degrees. If they give you radians, you're in radians. If you want, you can convert to whichever you feel most comfortable with. But what this boils down to is I have cosine 2 theta, which is 2 times 150 degrees, or what do they really want the answer of? Cosine of a 300-degree angle, which brings us right back to the very first week of stuff we were doing. I can draw a reference angle situation. That's a 300-degree angle. It has a terminal side, and I can make that into a right triangle, and I can label it based on this being my reference angle, and I say that's rad 3, that's 1, or you've already got your bow tie in front of you and you're working it, but that's got to be a negative because I'm in quadrant 4. And what is the answer they actually want from me? Negative rad 3 over 2. Just like these answers up here. Whoop, passed them. Some of these answers have rad 3s and rad 2s and whatever. That's what they're going to look like. Whoop, I don't know what that is. Okay, let's do this one. Now this one looks like the sine double angle formula. That one looks like the sine double angle formula. But I know that the sine double angle formula usually looks like this. So I can figure out, okay, this is what they want me to use for theta, but what's the deal with this? How come it's a 6? It's not a 2. Well, it's because they multiplied it by 3. If you take this side of the problem and multiply it by 3, that would mean you're taking this side to multiply it by 3. So 6 sine 15 cosine 15 degrees. They're just saying you're going to do 3 times the formula to get that. And then what am I plugging in for theta? It's 15 degrees. So this boils down to, if I want to answer this question, I'm going to say 3 times the answer I would get from sine of 30 degrees. And then I go reference triangle city, boom, bam. I got myself a 30-degree angle. That means 1, rad 3, 2. And I do the sine of that would be 1/2. It'd be 1/2. But I'm not done yet. They want me to multiply that answer that I just got by 3. So the answer they want me to have is 3/2. That's my second example. They try to trick us sometimes by putting a number here that is not what I'm used to seeing. But if they got a 6 here, the only way they did it is they multiplied the double angle thing by 3. That's how they did it. That's how they did it. So sometimes you have to be wily. You have to deduce what they're talking about. Now this one right here, example 3, 1 minus 2 sine squared theta. Whatever. This is the theta they're talking about. Well, what does this guy look like? This guy resembles my cosine double angle formula. And they didn't mess with it. This one's not messed with. I would say to myself, hey, they just want me to plug in pi over 6 here. And then that, what does that really mean? They want me to find the cosine of 2 times pi sixths angle. Oh, I'm going to reduce it. So they really want me to find cosine of pi over 3. And I go, heck, I've been doing this since day 1. I can draw myself a nice thing here. Boom. Got myself a reference triangle. That guy's pi thirds. And once again, if you know your stuff, you just rattle it off. And what's the answer for that reference angle? 1/2. I'm done. Cosine of pi over 3. It's 1/2. I know it. Now, here's where they start getting a little wacky. Because 1/8 sine 14 cosine 14 looks like the sine double angle formula. But I'm used to seeing a 2 here. I don't see a 2 there. I see a 1/8. Well, heck, what number would you have to multiply 2 by to have it say 1/8? And that number might not be a super pretty number. It might be a fraction. I'm thinking this, 1/16 times 2 would result in a 1/8 being in front of this. So what are they trying to say to me? I want to think of this as 1/16 times the normal double angle formula. That's what I want to think about. And if I do that, I would say, okay, fine. 1/16 times the sine of, times the, oh, sorry, hang on, let me back it up here. Back it up, sorry. I'm going to do this part. That's 2 sine 14, cosine 14, right? That's this part. But I'm going to take that answer times 1/16. What does this mean? This is where I do the 14 degrees. So what's 2 times 14 degrees? It's 28 degrees. So it's 1/16 sine of 28 degrees. Now stop for a second because that's done. We're finished. That's our answer. Our answers for this section, if I can find the exact value, I find the exact value. If I cannot find the exact value, I am supposed to leave my function as a single trigonometric function. That is a single trigonometric function. Now, I warned you when we started. Let's scroll back up to the answers. Here we go. See how problem 43, 44, 45, 46, 47, 48, all of those, they don't have rads in their answers. They don't have exact values because we don't have any special triangle tricks to find these kind of answers. What's the cosine of a 94.2 degree angle? That is when we break out the calculator. That is when you cannot give somebody an exact value. That's when you let your calculator do it. Same thing here, and then here they used radians. But let me go down because I made up some examples like that. So let's look at this guy. They say sine squared pi sevenths minus cosine squared pi sevenths. Now this one's sneaky because you look at that and your brain might go, oh, that's totally easy. That's cosine 2 theta right off the bat. You might say, yeah, totally nailed it. That's the answer they want. And what are they using for theta? They're using pi over 7. So you go, oh, well, that's easy. They want me to find the cosine of a 2 pi sevenths angle. And I go, wait a minute, I don't have any kind of special bow tie situation for this. So you might go, there's the answer. And then you scroll up to look at your answer on the answer key. And they have this answer. And this is the correct answer. This one's correct. Why? Well, let's talk about it. This is not this guy's wrong. But he's really close to being right, but close doesn't count. Sometimes we need to be right on. So what's up with this? Well, let's look at this. Just look at this carefully because they're going to try and do this to you in one of the problems. The cosine 2 theta formula does not start with sine squared theta. It starts with cosine squared theta. It does. So let's rewrite this, but realize that it's negative in the problem. That would make this guy positive in the problem. And then I look at that and I go, this is that stinky old negative trick. I got to factor out the negative. Then I could say cosine squared pi sevenths minus sine squared pi sevenths. Now it's a negative that I wanted. That's why they have a negative on their answer. So be careful because they will try to be tricky in the book. But if you check your answers, you'll go, oh, wait, there it is. Last one. This one is real sneaky because I look at this and I say to myself, you know what that kind of looks like? It kind of looks like this. It kind of looks like this, but I don't see a 2 here. And I see a 1/2 here. So what is this? This is supposed to be this guy. It is. And they gave me a theta, perfectly good theta. I can plug that in. But this thing is not what they gave me. It's as if they took my problem and multiplied everything by 1/2. See, if they took this setup right here, if they took this thing and they multiplied it by 1/2, then I'd get a 1/2 right here. I'd get the 2's to cancel. You see what I mean? So what they totally gave me is they gave me a 1/2 times my cosine double angle. So what does that mean? Not much. It means I have a half times the cosine of not 2 theta, not 2 times pi eighths, not this, this. So guess what? I'm going to find out what the answer to this is, and I'm going to take that answer and multiply it by 1/2, and then I'm going to match up with the answer in the book. And before I even draw, before I even draw this thing out, I'm hoping that you already know that this is like taking the cosine of a 45-degree angle, because that's what pi fourths would be, and that's just 1 rad 2, quadrant 1 style. And I would say that is so easy peasy. It's the same as 1 over rad 2, 1 over rad 2, but don't forget, they multiplied my formula by 1/2, so I have 1/2 times 1 over rad 2. It equals 1 over 2 rad 2. I get the rad 2 out of the bottom, and I end up with, don't blow it, what is the final answer? What is the final answer they want from us? They want this final answer to be rad 2 over 4. And that is an exact value. And that weird-looking answer there, rad 2 over 4, remember, answer key at the top. Hey, there's one that looks like that. So what I'm saying is, when you go through these problems, the first part is matching. I don't think you're going to have too much. I did this first example here with a tangent, because the matching ones are not that bad. It's where they try to mess with your mind right here. That's where you're going to have a little bit of difficulty. But hang in there. Just realize everything is exactly what it looks like. You just got to figure out how did they manipulate it or mess with it. And not everything turns out to be something we can draw a perfectly good bow tie style triangle